Welcome to a brief demonstration of the tools created for the Marine Biodiversity Observation Network, or MBON, for contributing to the United Nations Sustainable Development Goal 14, Life in the Sea. I'm going to go over two products, the Explorer and Infographics tools. You can navigate from marinebon.org by clicking on the SDG Products button. At the splash page, you can dive into the Explorer application and infographic examples for the coral reef habitat in the Florida Keys and the pelagic habitat in Monterey Bay. The goal is to allow data-driven storytelling. For the infographic, you can associate various elements of a habitat with time series data by clicking on a silhouette. For instance, by clicking on the temperature icon, you'll see a time series of sea surface temperature measured by satellite for the Monterey Bay National Marine Sanctuary. We can zoom into events such as the so-called warm blob, or marine heat wave, starting in 2014, to see the measurement compared with the mean, the dashed line in the middle, and the historical variance or standard deviation is the solid line. Other time series can be depicted below, such as difference from the historical mean, also called the anomaly. What's most interesting about this storytelling device is seeing how other elements also vary in time. So we see a phytoplankton bloom at this time, but not all primary productivity is beneficial. In this case, pennate diatoms released domoic acid, which contributed to the longest shellfish closure in Dungeness crab history, and probably had an ill effect on sea lions, as evidenced by the pup weight and growth indices. The interactive infographic framework enables easy visualization of these cascading and complex effects for a region of interest, potentially in near real time, which can inform managers for taking action and the general public for awareness on the state of the environment. The Explorer application allows you to create time series plots or maps that could populate the infographics or create a report for a region of interest. With a global view, the default regions for now are countries' national waters, also called exclusive economic zones. But these could also be large marine ecoregions, ecologically and biologically significant areas, key biodiversity areas, marine protected areas, or the like. Biological data is coming from the Ocean Biogeographic Information System, or OBIS, and our global data commons for marine observations of species. Clicking on the layer pops up some metadata. Clicking on the selector toggle changes layers, here from the number of species found in the EEZ to the number of observations. This application can be fully customized to a region and different metrics. Here we are experimenting with the protection metric, which combines OBIS observations with marine protected areas from the World Database of Protected Areas and the extinction risk from IUCN to come up with a ratio of protection, 1 being fully protected and 0 being fully unprotected. By clicking on Save Plot, we can change the title and add a caption. This allows us to share a link with a colleague or save as a report in various formats, which I'll show after saving a few more plots. Let's turn to the environmental layers. The first layer is chlorophyll, which is a measure of primary productivity. The time slider below shows the range of monthly dates available. We can click play and zoom around, or drag to a specific month. By selecting a region, either through the map or via the drop-down, we can then look at the time series, or select an alternative metric, such as temperature, and zoom to a time range of interest. Let's save this plot. Return to the map and save again. The seascape layer combines temperature, chlorophyll, and other ocean color measurements to come up with classes of water associated with different biological communities. Let's save this map. Looking at the time series, we can see how the area of each water class changes over time. Let's save again. Finally, let's generate a pretty PDF report of our plots. Saving as HTML creates a standalone web page that could be posted to a website or emailed to a colleague and maintains interactive capabilities, such as sliding the time range or panning around the map. These products are part of a larger vision to create a regionalized platform for consumption of globally available data, integration with local data, especially unpublished, generation of essential biodiversity variables at various levels of organization, from genetics to communities, and publication of novel products back to major portals for discovery and use elsewhere. We're hoping to ease the burden of synthesis and communication for biologically relevant data from scientific surveys and satellites to inform on life in the sea at local, regional, and global scales. These products were created using free software that works on any common computer platform, Windows, Mac, or Linux. The Infographic uses the statistical programming language R to produce web pages that could be hosted on any web server, even free ones such as GitHub. The Explorer app requires a stack of software on the server, which can be easily and cheaply spun up in the cloud within minutes. We hope to interact with a global community of marine data scientists to improve upon these products through open collaboration. Please visit us at marinebon.org, where you can find more information, and don't hesitate to reach out if you'd like to participate. Thank you.